Good afternoon, everyone. The House of Sultan and Sons Private Limited and methodAI extend a very warm welcome to all the participants of today's Artificial Intelligence webinar. It feels nice to have you all here, and we thank you for that. A bit about the House first. We are pioneers in the field of book publishing in post-independence India, catering to students from pre-primary to university level, churning out over 600 regular titles, besides adding new ones to our stable year after year. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in reputed schools, colleges across the nations, as well as in some neighboring countries. Our authors are distinguished academicians, professors, and educationists with vast experience and expertise. We are proud to be associated with them. I now introduce you to the host of today's webinar, Dr. Sachin Gupta, author of Artificial Intelligence and Data Science books for classes 9th and 10th. Besides, Dr. Gupta is Dean, Research and Innovation, Maharaja Agrasen Institute of Technology, GGSIPU, Delhi. Dr. Gupta has also been HOD Computer Science Engineering and MCA Department in Dronacharya Group of Institutions, Deputy Director and Head of the Computer Science Department in Chandraprabhu Jain College of Higher Studies affiliated to GGSIPU, Delhi. With a teaching experience of over 20 years, which includes teaching undergraduate and postgraduate students and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGSIPU. Dr. Gupta has also contributed to various journals, conferences, and books for schools and higher education, both nationally and internationally. His achievements are truly commendable. May I now request Dr. Sachin Gupta to take you through today's webinar. Dr. Sachin Gupta, have a great day ahead. Thank you.
Thank you so much for the introduction, sir. I believe that was a bit more generous than I believe. Okay, so we are currently in the fourth set of the series on artificial intelligence, and today's session is special because we are looking at now what is the confluence of the two streams that are introduced by CBSE in the skill-based subjects. The first being artificial intelligence, and last year the data science was also introduced. And there has been a lot of discussion about both the things, that how are they related. There are a lot of queries that faculty members from even higher education institutions are asking, that there is a lot of ambiguity when we talk about data science. So I wanted to set the record straight for that part first, and that is what we are going to start with today. In case you have any queries, for those who are watching on YouTube, kindly send the queries there. I'll get them forwarded. And for those who are joining us on Zoom, they can put the query in the chat box, and I look forward to them. So the data science, basically, broadly speaking, is an interdisciplinary field that is using scientific method, processes, algorithm systems. But the basic purpose of data science is to extract insights and knowledge from structured and unstructured data. This is a very general definition. I mean, I would not say that this definition is universally accepted. But in general, whenever we are extracting insights and knowledge from structured or unstructured data, that basically pertains to data science. So there are a lot of streams that are mixing in this, like statistics. The knowledge of stats is necessary, mandatory even for data science. For AI, not so much, but for data science, absolutely essential. Mathematics, computer science, and in fact, domain expertise, because data is coming from so many varied domains that for us educators, the data related to our students, their result, their performance, that is academic data. One look at it, one look at the rubrics, you'll be able to tell that which students are performing good, which students are performing bad. That is your domain expertise, or my domain expertise for that matter. For somebody like my publishers, when they are selling books, they would be understanding the market, that what kind of books sell, what is the numbers, which schools are available in which district, then what is the sales over a specific state or a territory. So that is their domain expertise. I see something on the chat. All right, I'm missing the video, I believe. Let me try. I can't seem to set the video on. I hope we can continue without it if it is not working. All right. So I was talking about data science in general, that it's a combination of stats, mathematics, computer science, and domain expertise. Further to that, there is ambiguity in the terms of that when I was working with the CBSE syllabus, then for Unit 1, there was a lot of give and take between me and the my editors, that data science, I looked at it as a domain which was exclusive of AI, which was something which was assisting AI. But then CBSE curriculum had mentioned very clearly data science to be a part of artificial intelligence domain. So then I explored further, and I could come to both definitions. That data science as a broader domain involves some aspects of data which include cleaning of data, exploring, visualization of data, feature engineering, and model evaluation. That these domains are specifically related to data science, but there is overlap that these domains are also coming in parts of artificial intelligence as well. So far as in data science as a general domain is concerned, these activities are not limited to any specific type of data. They can encompass both structured and unstructured data. And data science is, as per the previous definition, it is extracting meaningful insights and knowledge from data regardless of where it is originating. Further to this, this was the ambiguity. This was something that we were actually worried about, that what is actually data science doing in the AI domain, or is it a subset of AI, or is it a parallel set to AI? So this definition is actually a subset of AI. There is a specific subset of data science that focuses on working with non-image or non-text data for prediction. So frankly speaking, AI can be divided broadly into three categories. On one hand, we would be having data which pertains to numbers or statistical data. Then there is image data or video that is specific to computer vision domain. And then there is a third kind of data, that is the human language, the text, the chat GPT, for example, that you use. So that all comes under the natural language processing. So this specific field of data science, which is a subset of artificial intelligence, this is used to perform tasks like regression analysis and machine learning, which is applied to structured data like numerical or categorical. So whatever data that we have in the form of a table or a CSV file, that if we are analyzing that, or if we are making predictions on that, that is usually considered to be a subset of artificial intelligence, which speaks as data science. So this aspect of data science is related to predictive modeling and statistical analysis, unlike the one which we spoke about earlier, which was about cleaning of data or pre-processing or visualization. All of that can be considered exclusive of artificial intelligence. I hope there are no queries so far, so I'll take it forward from here. So data is considered to be like a faint light when you are lost in a dark room. If we follow data, if we try to make sense of it, we might actually know where we are and what is around us. Now, this is interesting. Why are we interested about data science now? Why are we interested, or why is AI coming out of the AI winter that was in for so long that till the year 1995 or so, AI was not a buzzword. But after that, the data grew so fast and artificial intelligence grew parallelly. So, from the graph, you'd be able to see that the graph states in 2010 we had 2 zettabytes of data over the internet. In 2012, that grew to 6.5. In 2014, that grew to 12.5 zettabytes. In 2020, between 2018 to 2020, just look at it. The 33 zettabytes of data that we had in 2018, by 2020, it grew to double. So the amount of data that we were working on for the last 25 years of internet, it suddenly grew to double, and it is actually expected to grow exponentially now with the graph that you can see. So where is this data coming from? How are we actually generating so much data? So that you can see from the slide, how much data are you generating? How much data am I generating every day? So when I made this presentation, this was addition to the existing data that was available on the internet, even putting a link out. So in a minute, from the slide, you'll be able to see that people send 16 million texts. Facebook users share 1.7 million pieces of content. Google users conduct 5.9 million searches. 1.4 million email messages are sent. Then Twitter users share roughly 347.2 thousand tweets. Snapchat, Tinder, YouTube, with 500 hours of video uploaded per minute. So the kind of volume that we are generating every day with our social media, Instagram, WhatsApp, everything contributes to data now. So this is the kind of data explosion that we are sitting with, and that is where the data is coming also from. So what was just 2 million user queries on Google in 2013, in 2022 it was 5.9 million, roughly 3 times increase. YouTube hours uploaded from 48 hours per minute to 500 hours. And you can say similar statistics about, except for the emails, which remain more or less static because they were in use back then also in good numbers. But for Twitter, for Instagram, for Facebook, the content sharing is growing. And now this content is both structured and non-structured. That means the images, the videos, the text that we are uploading, most of it is unstructured. But when we have data in the tabular form, that goes into the structured part of the data. So there are sources of data which includes, traditionally we had databases, the legacy documents that people used to keep documents in the form of Word files or even the printed document. Then media, whatever data is uploaded to the cloud, from cloud to the web, for the Internet of Things, which are generating a lot of data these days, then social media, influencers, activity generated data, even the watch. If we are wearing a smartwatch, it is generating a lot of data just by the movement of a person, not even requiring any other source. And all of this data goes into data warehouses and appliances and through the network coming back to the databases. There's a huge cycle that is going on and on about data being generated, stored, processed, and shared amongst people. So, how did this help towards AI? That comes next. So, what happens is that in 21st century, information is considered to be the most vital resource. And with so much data coming, it is actually impossible to process all of that unless and until we have some means of analyzing this data. So information is at oil of 21st century, and analytics is the combustion engine. That was by Peter Sonnengard, a senior VP of Gartner Research. And this holds so true these days that whatever we are working on, if there is analytics involved, we are getting far more insights from the data as compared to any time earlier. So here is the promised part, that what is the relationship between data science and artificial intelligence per se. We start at the very beginning, that before artificial intelligence was cool, before data science was also considered to be a domain, even before that data existed, and data had been in existence for a very, very long time. But the domain which was actually working on data, that was statistics. So most of the surveys, most of the predictions, most of the models which were using that, making a prediction about an election, or making a prediction about the consumption, or making a prediction about the marketing, sales, anything, that depended a lot on statistics. We used to select or collect the data, analyze it, and interpret it. All of that was part of a statistical domain. Now, statistics work good. What was the need of actually thinking about data science or artificial intelligence? That was not required. If if only statistics could have worked with the same volume of data that we are currently running, and not only that, that the data volume was not a problem. The other issue was that statistics typically work with structured data. The statistics would work with data which is in the form, which is usable, which would be put in the form of a table, and with tabular data we'll be able to process. Even with statistics and so much data being generated, with even the structured data, there was a lot of noise, there was a lot of error, there was a lot of data which was missing. So all of that contributed to, with so much data being generated now, artificial intelligence took a front stage, because AI feeds on data. Any artificial intelligence system, be it data science based, be it computer vision based, be it natural language processing based, all of them thrive on learning from data. Unless and until we have a lot of data about some phenomena, we will not be able to actually make the artificial intelligence system learn. So, for a very simple example that you can consider, that I have to identify between a dog and a cat, that is the usual example that people say. So, I need to have a lot of images of dogs, that these are dogs. I feed it to my AI system with a label that these are dogs. I also must have a lot of images of cats, and I would label them that these are cats, and let the system learn from the features of that dogs have these features, cats have these features, and it identifies them separately. So that is the importance of data for artificial intelligence. If I have to learn about prediction of stock prices, I should have the stock price data for the last 100 maybe months, or maybe 100 years. That may help us to predict the stock prices. But summarily, you get the gist that wherever there is AI, the AI system cannot survive without data. In fact, people have gone to state that any AI system is only as good as the kind of data that we are feeding to it. If the data is bad, the AI is going to make bad predictions for sure. So if instead of dogs and cats, if I am giving it images of some other animal in the name of dog, it might predict anything as a dog, as long as it does not understand that the data that was given, it was bad. So our responsibility for running any AI system smoothly is required that it should have a very good amount of data, and also it should have a very good quality of data. We can compromise on the amount of data. If we have less data but of a very good quality, my AI system would still work. But if we have a lot of data and that is a bad quality or poor quality, it would not work. We have to filter it, we have to clean it, we have to make the data good to be used for a AI system. And that's where data science comes into picture now. So data science, in the general definition, where I would be able to explore the data, I would require to clean the data for if there are noise available, or if there are some missing values, or if there are some values which are outliers, all of them need to be cleaned. If, let us say, I'm measuring the ages of people, and age versus the salary, and I find that ages of 200 or ages of -10 or age value is 300, then all those values are impossible. So if these values are impossible, then they require cleaning. We can say the age would be between 1 year or 0 years to let us say 100 or 110, and even 100 or 110 would be a very huge value. It's an outlier by and large. So taking an average age to be between for earning, a person would be starting at the age of, let us say, 16 or 17, and they can go up to earning till the age of, let us say, 60, 65 when they retire. So while cleaning, we are going to keep this in mind that the data usually should be this, and anything beside that, so any negative value for a age is certainly wrong. So while exploring, we come to see what kind of data we have, then we clean, then we normalize. Now, normalizing is a concept where if I have two or three different values or two or three different features of data, like the height of a person is in a single digit, maybe in inches, maybe in feet, 6 feet or 7 feet or something, the single digit. The salary of a person might be in a very 4 digits, 5 digits, 6 digits, or 7 digits. And then there may be some other aspect which is a 2 digit factor. So if we have to treat them equally, and if we want all of these factors to be given equal importance, we might have to normalize them to the similar scale. That either all of them would be in 2 digits, either or they all of them must be converted to a single digit value. So we need to understand what is the impact of which particular data value, and we have to normalize it. That basically the part of normalizing. We do some feature engineering. Some features might require to be added together. Some features might require to be squared or square rooted. That goes into it. And then we scale. So when we have clean pre-processed the data, only after that we come towards the AI, which in the terms of creating a model. This model is the one which is a mathematical model, or which actually finds out what is the mathematical relationship between the different domains or different uh, what you say different observations or different features of the data. They are all fed into an algorithm which results into a model, or which results into a mathematical relation existing between the different features. Like, it might be giving us a good result, it might not give us a good result immediately. So we need to tune it, we need to evaluate it. We choose a model, we train the model, and then we keep on going through the cycle of evaluating and tuning it finally. So this part was from statistics. We have gone to data science. From data science, it supported artificial intelligence in a long way. And eventually, when we have created a model which is good, which we understand that can generate value, like let us say I got a lot of data on the stocks, and then I created a model which could predict the value by which a stock would rise or a share would rise. I can convert that into a software which would make it operational. I would deploy it. I would keep on monitoring it, that what kind of responses are my predicted values and the expected values same or not? Is the stock rising as per my model predictions or not? And then if it is required, I might require to retrain the model also. So that basically is the big relationship that actually joins data science and artificial intelligence together. Have a look at the chart again, and if in case there is anything, any query that you would want to ask, please share. Now, nothing on the chat window? Oh, sure. Let's go ahead. So, when I teach data science, I usually take a very simple example, an analogy, the way we teachers do, to make it understandable. So let's look at an analogy where data science comes into picture, and we are going to compare it with a cooking example. So, what do you do when you want to cook a good meal? You need to first start out with a new dish. You need to understand what the current menu is missing. you need to understand what is the requirement. In the terms of a problem statement, you can say that I'm trying to find out that what is the problem to be solved. Right. If it is a data-driven approach, you are going to collect a lot of data to solve that problem. So similar to collection of data for problem solving, we have the ingredients here. So for food, if you want to cook a good meal, you would require the ingredient, which is data in the case of AI-based problem. So for the food, we might have to go to the market, purchase the different ingredients. For data science, we might be gathering our ingredients or data from web scraping, SQL, from data sets. So the raw ingredients are like raw data. Now you can't work with dirty ingredients, like you need to wash your rice, your vegetables, your chicken, whatever that you are cooking. You need to clean it, wash it, make it suitable so that it can be applied to that. And then you chop or adjust the portions as per the size, because if you put in a too big a piece of a vegetable, it might not cook. So you have to find an optimum value, that what should be it chopped to, or what should be it adjusted to. That is same in data science, where we adjust the different parameters which are being fed to a system by adjusting their value, either by using logarithmically, or by taking a square, or by taking a square root. That goes into feature engineering. Going forward, you may taste and explore. You may actually uh, try to understand what is the flavor profile of each of the ingredient. Similar to what we do in cooking, in data science, we do a exploratory data analysis. We try to understand what is the relationship between our variables, that which of the variables always grow together, which of the variables are always opposite, that one grows, the other uh, decreases. So that kind of relationship that we try to find out between the data values. And finally, based on the problem, we try to see that what kind of model might be best. So in AI, that goes to like choosing whether we are working with numerical data and we want to have a regression analysis, or we may have data which we do not know anything about. It's unsupervised, unlabeled data, and we try to do clustering, that grouping people into some different group by the way of their interest or something. Or we might want to classify like emails, do spam and non-spam, or loan prediction may say this person may default the loan, or the other person may not default. So all of this goes into uh, the choosing of the model. So from the previous, that taking raw data, starting with a problem statement, taking a raw data, cleaning, pre-processing the data, feature engineering the data, finally going on into exploratory data analysis of the clean data, we now can select a model, and depending on the model, we will now do fine tuning, that we have actually decided that this is what we are going to do. We are going to either bake or grill or choose our AI model. But after how long do we have to cook? Should we cook it for 50 minutes, 55 minutes? Should we let it simmer for very long? So what temperature should we use? This is model tuning. So for the same model like baking or grilling, different problem statement may require different time for baking, different time for, or different temperature for baking, or different ways. So that is equivalent to hyper tuning or hyperparameter tuning or model tuning that we require. And finally, we validate that, do people like what you have produced? Are the results from your model good? Does the model work on test data also? So that is validation in a loose sense. That validation is a very broad, specific term, but you would be able to actually say there are a lot of things that go on in validation. Which one of these are you actually saying that applies? So we'll say in general, let us say we want to evaluate how our dish is. We give it to different people. We ask them to taste. Somebody says the salt is less. So we go back to the tuning and we might add more salt. So that is after the evaluation, we might go back. We might have missed some ingredient. In fact, that might also be possible. So in case we have missed some ingredient, we would add that and then come back to evaluate again after applying the model, tuning it. So that way, it kind of works. And what happens after this is we have developed a model, we have fine-tuned it. We now want to present it to the people in a form where they enjoy looking at the data. So this is again a data science domain thing, that we have to produce beautiful visualization that add to understanding of a work. That whatever output is my AI model producing, we want to show it as a graph or a plot, like you draw ROC and AUC curves to understand that how is my model working. Or you may want to present the prediction of the sales in the form of a graph or a bar chart, which shows how the data is going to work. So that is about data visualization. It's usually considered to be a part of data science more rather artificial intelligence. And finally, you document it, that you document your code so that if you want to repeat the same process with some different data, you will be able to do it again. So that is an analogy which we usually apply with data science and artificial intelligence. How do they both complement each other? How do they both add value to each other for a long-term success? All right. So moving from the analogy to the actual process of data science, it says we have to collect the data, clean, do an exploratory data analysis, build a model, and deploy the model. So there are three kind of people which are associated with it usually. And the people who are data engineers, they'll be interested to collection and cleaning of data. The analysts come with the cleaning stage and do exploratory data analysis. And the machine learning engineers are more interested toward building the model and model deployment. And all of them together can be called a data scientist. So data science is a term which encompasses all of these three. They are not restricted to either engineers or analysts or machine learning engineers. They take all of them. Are there any queries from the people on YouTube? None. All right, let's move ahead. So data science has a huge landscape. We will again see that what is the relationship between data science and AI and where do they differ also. So the landscape of data science is actually providing statistics into where it is going to be used and what is going to be the impact. By 2026, it is assumed that data science will create around 11.5 million job openings. That includes people who are into data engineering or including the machine learning engineers. Okay, I just clicked on the link by mistake. Then the average base salary for data scientists in the United States is a huge number, even for today. For every 3 people applying for a job, one job would be in data science domain. It is expected. 95% companies say that managing unstructured data is a challenge for them, and big data analytics market is expected, not it has actually exceeded the 2023 predictions by a wide margin. Now, so let us look at the data science landscape, because I told you that AI and data science are related, but they are different as well. So data science landscape can include software engineering, which was a very general definition of creating data earlier, but it also includes the data pre-processing. Data pre-processing talks about obtaining, handling missing data, cleaning, feature engineering, feature selection, as we have discussed. This landscape also includes mathematics, including linear algebra, discrete math, because these are the things which are working. Let us say I'm working on a regression model. So regression basically comes from linear algebra. What is the relationship between two variables? That comes from algebra. And if it is multivariable, then it goes into further advanced models. Then we work on a lot of matrices when we are working with, because pandas is a Python library. Whenever we are working with tabular data, we usually work it in the form of matrix. So mathematics is one specific domain again. Then statistics, of course, it's the foundation of all data science. So how do you create a design which is experimental, then descriptive statistics or inferential? A lot of programming is needed in the domain, including the languages which are working toward data science. Specifically, some are like Python, the most famous that we are working on. R programming language, Java, Hadoop, SQL, C++, Julia, Scala, Spark. They all have their own advantages and disadvantages, and people who are working with AI, they may look forward to some language which works good, equally good on both data science and artificial intelligence. Those people who are working only with data analytics, they might want to work with a different set. Those people who are working with huge amounts of data, they try to work with Spark or Scala because or Hadoop, that where data has to be broken into parts before it can be processed. A set of data science goes into data visualization, exploratory data analysis, which helps with understanding what the data is. This is a crucial stage before machine learning also. And then after the results come, then that visualization, even from a machine learning model, that data science handles. Right. Then you have a very wide domain where you can see that machine learning, when it comes to deep learning or back propagation or support vector machine, random forest, decision trees, regression, supervised and unsupervised learning, all of the machine learning is also considered to be a weight part of the data science domain. And then you can add in soft skills and the other parts. So most of the work works around mathematics, statistics, and these are the points which I tell that if you are aspiring to be somebody who wants to work in the domain of data science or machine learning, we can either start with maths and stats, or you can start with coding, take to maths and stats, or data visualization. If you are not interested in anything like coding or mathematics or statistics, add with a domain knowledge and a little bit of machine learning, and you are set. So this is about the relationship existing between data science and machine learning. So you can say the data are just a summaries of thousands of stories. You can tell a few of those to make the data meaningful. That's about. I'll throw the floor open for anybody who is listening in, who have tuned in, and who have any queries related to how do we teach it in the classroom, or some analogy that they want, or anything from the presentation that you want me to elaborate more on. I'm opening the chat window so that you may want to share any of the messages that you want to add in. Any queries from the YouTube, sir? I guess the session went either too well because there are no questions, or there are so many questions that uh, please understand one thing, that no question is not important. So if you have anything in mind, anything that I may learn from, your questions are most welcome. In case you are wondering that whether the question should be asked or should not be asked, please feel free to ask. I guess that's about it. Okay. So Vijaya has asked that how do students understand storage of unstructured data? Okay. Vijaya ma'am, there is a very simple rule of thumb that if my data is having either a tabular format or it is in a format which can be easily converted to a table, that is structured. But anything which is not into either of these formats, anything which is loosely shaped, anything where we cannot clearly distinguish between different parts of the data, that would be unstructured. So, if you are having a lot of, let's take an example of Facebook, for instance, your posts may contain an image, your post may contain a video, your post may contain only text, your post may contain a lot of comments. But if I am putting all of that into a table, that this is the person, this person created a content on this particular time, and the post contained the image, the post contained some text also, the post contained some comment also. That table itself might be structured, but the image which they have inputted, that image or the text that they have used, that might be unstructured. So any data which is in the form of a tabular or which can be easily converted to a table is structured. And if the data is not amenable to being converted to a tabular form, that would be unstructured data. Okay. So Rinku asked that please give an analogy for regression. Regression, I'll take a very simple example for time and distance, let us say. So going from my home to the airport, the distance is 15 kilometers. Okay. I may want to draw an analogy. I may want to draw a parallel between that. How much time should I take to go from my home to airport? So for 15 kilometers, let us say my time is 1 hour. So can I say for 30 kilometers, the time would be 2 hours, or for 45 kilometers, the time would be 3 hours? This is the normal relationship that I say for a regression that happens. But in real life, this does not work, because when I'm going from my home to 15 kilometers, the same, I would say the time varies between, because there may be some traffic. So the traffic is heavy or less. That is one dimension of data. That is one feature. Then whether it is a weekday or a weekend, that is the second dimension of data. That another feature. It might be a day when there is a public holiday. That might be a third criteria. It might be depending on whether I am traveling in the morning or afternoon or in the peak office hour. That is the fourth dimension of data. Now, when I'm going to now create a regression model, I would be predicting the same thing, that how much time would it take. But instead of only the distance, I have to figure in a lot of different parameters. So instead of my equation being x into some number plus y into some number equal to distance or time, now it would be having a lot of different parameters which are going to contribute in different quantities to the same prediction, that is time. So that is one analogy which you can actually take in for a regression algorithm. Okay, Richa, it's very easy. Just ask them, take two variables, for instance, age and salary, and you can ask them to collect data first and plot a graph, simple XY graph as we draw in the mathematics class, and let them draw a line which actually touches the maximum amount of points, or which actually covers the most amount of points without touching all of them, but a straight line which goes through all of them. And then say that if I have a age of 20, then what would be the salary, because that is not on the line. Then ask them to find a plot on the y-axis which is going to be able to predict that. So regressions are simple mathematical equations which allow you to calculate the relationship between two variables on the easiest point, and much more than two variables using machine learning, which the machine learns by itself. Because we as humans cannot think beyond two or three or four domains or dimensions. That time और distance तक तो ठीक है, लेकिन day, time और distance होगा तो क्या करना है, या day day of the time of the day, distance, ये सब भी चीज factors देखने हैं तो क्या करना है, whether I'm going out of city or in the city. If I keep on adding more dimensions, it becomes difficult to predict regression by manual method. Their machine learning helps. Okay, let us say, can C or C++ be used for AI programming? Very interesting question. Later, there is a simple thing that when we were working on artificial intelligence systems in 1970s, 80s, the expert systems were more like simple decision-based models. So anytime when we are making a rule-based AI, for any rule-based AI, the C or C++ programming language would work very good. There is no problem working with that. For a scheme where you want to learn more by the system themselves, it would help if the programming language is having libraries like Python has sklearn. So for those developers who are working with Python, whatever they develop, they contribute to the community. So those libraries are helping others also. Unfortunately for C and C++, not much work has been done towards the library, but for a rule-based AI, you will be able to create it perfectly fine. Keep them coming. They are interesting queries that we are getting today. Anything from those who are the Zoom? I hope I have answered the questions. Anybody wants a follow-up question from YouTube? We look forward to that. If you need more clarification. Okay. Sudha ma'am says, can we become data scientists without math as a subject till class 12? Okay, Sudha, this is a good question. Let me get back to the slides. Let me clear this window out. So I told you data science landscape is huge. While some majority of the portions, like if you do not have mathematics and you are interested in statistics, you can go toward data pre-processing. If you do not want to do either of them, you may look forward to data visualization also. And even in fact, there are people who require to who are storytelling people who do understand a graph and they can put it into a succinct word that people can understand, or who can put it into a visualization which would be very easy to understand. So you can still become a sort of person working with data science, but not exactly a data scientist, because that is not. And trust me, there is a lot of abstraction that is happening. The abstraction being that people are not using mathematics or linear algebra. I don't know. I would not say that you require to learn linear algebra, but if you can learn Python and if you can work on data science using Python, so whatever matrices or linear algebra or other things it is doing, they are all handled by itself. So you do not require to learn them unless and until you want to go deep into it. So that's also, I hope, Sudha, I have answered your question. And I'm sharing my mail ID. So in case there are more queries, you can always send a mail on. This is my mail ID. Please share it in case if you have any queries further to this, and I'll be very happy to handle them. Without the camera, today's session was more like a podcast instead of a session. But I hope there is a good takeaway value from the session today. Thank you everyone for joining us. Please share your feedback about the webinar. Thank you so much for joining. I hope we can close in case there are no more queries.
Yes, sir.
All right.
Thank you, Dr. Gupta.
Thank you so much for everyone for joining and for the queries, especially.
Like earlier sessions, today's session too was quite informative and engaging. As you all know, our AI webinars are held every alternate week, today being the fourth in a row. Do join us in the next webinar, about which you will be duly informed and get benefited. Thank you once again. Have a
And
great
please,
weekend. Thank
please
you.
share suggestions. If in case you want the session to be conducted on a specific topic, we'll be open to taking it up. Because we are
Yeah,
giving to the teacher community anything that you might want to ask. Please do share your feedback on what kind of or what topic of the session that you are looking forward to, and we'll add them.
that'll be wonderful.
Thank you so much. Thank you
Thank
so
you.
much.